have a problem here involving composite functions that we've looked at and exponential functions. And what I'm looking for is, what function do I need to complete this transition? What you'll find, and you may already have found, is that dealing with the exponential function with the base e is very handy, very convenient, but unfortunately sometimes you have to deal with a different base. And what you're going to see is the transition necessary to get from one to the other. But let's write this out. What is f of g of x? Well, what does f do? It takes what's ever in here, which is g of x now, and puts it in the exponent. So we have e to the g of x. And supposedly this is supposed to equal b of x. And now what? Well, how do we get rid of the exponential function? How do we get the thing we're looking for out of the exponential function? That's where the inverse function comes in. We take the ln of both sides. Taking the ln of this side just gets rid of the e. So we have g of x. I have to take the ln of the right side. And there it is. That describes the function. This isn't exactly in the form you'll need it. You'll probably need to use another fact of logarithms that you've seen before. The log of something to a power is the same as bringing that power out front as a coefficient. And so the form that you most often need it would be, it's simply x times the ln of b. And in a particular problem, you know what the base will be, and the ln of that is simply a number. So in fact, all you're doing is multiplying your x times a number. But this is the connection. And so in dealing with different bases, what you're going to find is that you have factors of ln of b floating around. When you need them, you'll have them. But that's the function we